Today, we are going to talk about the working of pointers, a much dreaded topic in C. After this video, with the examples that I provide, I'm confident you will have a fundamental understanding of what pointers are and how they can be implemented. I am Imtiaz Sayed. Let's get started. Let us take a look at the definition of a pointer. We will revisit this definition after an example, so don't worry too much if it's not making much sense. Pointers are special variables capable of storing a memory address. So, how normal variables store values such as 10a, 10.5, etc., pointers store the addresses where those values are stored rather than the value itself. Let us understand pointers with a simple example. Let us say that you are going to school. There, you have a locker that has the number 10 on it, where you keep your books. Now, when you reach the school, you find out that through some error on the school's part, you have now received a new locker, locker number 1. However, all your books fit in just one locker, so you don't really need a new one. But you think to yourself, maybe a situation will arise where you might need the additional space. So you decide you will keep the locker empty until you need it. You have had the locker number 10 for years, so you remember the number 10 and are habitual to go there. And you feel like you will forget the new locker number, so you come up with this creative solution. You go ahead and keep your books in the new locker, locker number 1. And in the locker number 10, which was your original locker, you stick a piece of paper with the number 1, so you are reminded that you are using locker 1 henceforth. In such a way, you will not forget the new locker number, and when you reach the locker number 10, it will point you to the new locker where you can collect your books. Let us relate this to the computer's memory. Please note that this is an oversimplified representation of the computer's memory, just meant for the ease of understanding. The grid view on the right represents the computer's memory. The numbers at the bottom of each box represent the location of that particular block in memory. These numbers are represented as hexadecimal values. This block is simply a container with an address where we can store values. These containers are where the values of the variables we create are stored. Now that we actually understand this, the locker number 1 is where my actual data is stored. So let us take that to the memory address 0x101. Now in the locker 10, we want to keep the number of the locker 1. However, our data is stored in memory location 0x101. So instead of the number 1, we will store the address of 0x101. Now let us revisit the definition again. Pointers are special variables that are capable of storing memory addresses. Hopefully this demonstration of how they are stored made this concept really clear. So now that we understand this completely, let's take a look at the new syntax we require to implement it. There are mainly two new pieces of syntax you require to work with pointers in C. The first one is an asterisk, which we call a dereferencing operator. This operator allows us to do two things: declare a pointer variable and get some value stored at a memory address. The second one is an ampersand, which is called an address of operator. This operator allows us to get a variable's address. Don't worry if this is not making too much sense, you will understand in the following implementation. Like I said previously, to declare a pointer, we use the asterisk or dereferencing operator. We specify the data type followed by an asterisk symbol, which is followed by the name of the pointer. The only differentiator between this and declaring a variable is the asterisk symbol. It is important to note that when using pointers, they can only store the addresses of variables who have the same data type. So integer pointers can only store the address of integer variables. Float pointers can only store the address of float variables, and so on. Let us now move on to how pointers can be implemented. First, we declare a normal integer variable, locker1, and give it the value of 10. This integer 10 represents the number of books stored in locker 1. Now we want to store the address of this locker in locker number 10. So first we create the locker 10 pointer and we do it as shown. Then we assign the address of locker 1 using the address of operator, which quite literally gives the address of whatever variable follows. Since the variable and the pointer are of the same data type, this is a valid assignment of address. Now when we want to get the data of locker 1 through pointers, we use the dereferencing operator, which is the asterisk. This will look at the address stored in the pointer. Then it will go to that particular address and then pull out its value and give it to us. Then we can print it as shown. If you want to see the address stored in the pointer, simply print the pointer itself without dereferencing operator and add the %p placeholder in the print statement. Let's quickly recap these steps. First, we declared a pointer using the asterisk symbol to create the pointer variable. Then we assigned the address of the variable of the same data type to the pointer using the ampersand symbol, thus giving us the address of the variable that follows it. Finally, to get the value from this pointer variable, we use the asterisk symbol or the dereferencing operator again to retrieve the value from the address stored in it. Pointers are widely used in data structures such as linked list trees and such, which I will soon cover in my upcoming videos. Hopefully, this has cleared up how pointers work. If you have understood the concept of pointers, please leave a like and subscribe so you don't miss any of my example based simplification of programming concepts. Thank you so much for watching. Have a great day.